Hi sir, I'm Cole. So today I'm going to talk about a Unit 3 video assignment. The question is use a curve sketching a gradient from class to create a full solution and a sketch of following function. The function is fx is equal to 200 plus 8x to the power of 3 plus x to the power of 4. So at first from this function we can know x could be any real number. This is function's domain. Um, so then we can calculate the function intercept. The y-intercept is make x equal to 0, so get y equal to 200. So y-intercept is 0 to 100. Next is x-intercept. We need let y equal to 0, so we can get x value is equal to negative 3.5 and negative 7.5. So y-intercept is negative 3.50 and negative 7.50. Next is symmetry. We let x change to negative x, so we can get f negative x is equal to 200 minus 8x to the power of 3 and plus x to the power of 4. Because of f minus x, f negative x is not equal to fx and it's also not equal to negative fx, so the function has no symmetry. It also no symptoms. Next step, let's change this equation into a derivative. Is become f prime x is equal to 24x squared plus 4x to the power of 3. Then we can simplify it. We can pick up common factors. Then it's x squared, then become x squared bracket 24 plus 4x bracket. Then we let function equal to 0 to calculate the x value is equal to 0 and negative 6. So we get the critical points is negative 200 and negative 6, negative 6, negative 232. Then we can use a table to analyze the behavior of the function. We can see that the f prime x from negative infinity to negative 6 is negative, so the fx should be decreasing, and f prime x from negative 6 to 0 is positive, so fx should be positive. F prime x is also positive from 0 to positive infinity, so the fx is also positive here. Using the information from the table, we can see that there is a local minimum value of function at x equal to negative 6, since function values are decreasing before x equal to negative 6 and increasing after x equal to negative 6. We also tell that there is neither a local maximum nor minimum value at x equal to 0, since the function value is increasing towards this point and increasing away from it. Next step, make a second derivative, so we get f prime x equal to 48x plus 12x squared. We can also pick up common factors. Is 12x, so we can get 12x bracket 4 plus x bracket. We make the function equal to 0, we can get the x value is equal to 0 and negative 4. So we get inflection points is negative 2 is 0 to 100 and negative 4, negative 56. then we need to determine the sign of f prime x use the table. So from the table we can know that fx is concave up when x less than -4 and greater than 0. And when x is greater than -4 and less than 0, the function, the fx is concave down, and fx has inflection points at 0 to 100 and 0 to 100 and -56. So next step, we need to make a table again. We need to write all x value and the y value we get before in this table. So we get these values here, and we can make the point on the graph. We get 5 points here, so we can connection each point. So we can get the final answer is this graph. We can see at this point, this is the minimum point. The value is y is reflection point, and the x value is equal to 0, the y value is 200. So this is my answer. Thank you.